Multiplication theorem of probability. We know that the conditional probability of event E given that F has occurred is denoted by P of E by F, which is equal to probability of E intersection F divided by probability of F, given that probability of F is not equal to 0. Now this can also be written as probability of E intersection F equals probability of E given that F has occurred into probability of F. Now this is equation number 1. Again, probability of F by E is equal to probability of F intersection E divided by probability of E, given that probability of E is not equal to 0. So here again we get probability of F intersection E equals probability of E into probability of F given that E has occurred. This is equation number 2. Now from equation number 1 and equation number 2 we get probability of F intersection E equals probability of E given that F has occurred into probability of F, which is also equal to probability of E into probability of F given that E has occurred. This is known as the multiplication rule of probability. Let's take an example. An urn contains 10 black and 5 white balls. 2 balls are drawn from the urn, one after the other. What is the probability that both drawn balls are black? Solution. Let E equals first event drawn ball is black and F be the second event that the ball drawn is black. Then we have to find P of E intersection F or P of E given that F has already occurred. Now total number of balls equals 15 and probability of E, that is probability that black ball is drawn in the first draw, is 10 by 15. Therefore, the probability that the second ball drawn is black given that the ball in the first draw is black is nothing but the conditional probability of F given that E has occurred. Therefore, probability of F by E equals probability of F intersection E divided by probability of E. So, by multiplication rule of probability, we have probability of F intersection E equals probability of E into probability of F by E. Also, probability of F by E equals 9 by 14. Therefore, probability of F intersection E is equal to 3 by 7. Multiplication rule of probability for more than 2 events. If E, F and G are 3 events of sample space, then we have probability of E intersection F intersection G equals probability of E into probability of F by E into probability of G by E intersection F, that is equal to probability of E into probability of F by E into probability of G by EF. Similarly, the multiplication rule of probability can be extended for 4 or more events. Example: 3 cards are drawn successively without replacement from a pack of 52 well shuffled cards. What is the probability that first 2 cards are kings and the third card drawn is an ace? Solution: let K denote the event that the card drawn is a king and A denote the event that the card drawn is an ace. So we have to find the probability PKKA. Now probability of K equals 4 by 52. So probability of K by K is the probability of second king with the condition that one king has already been drawn, and the cards now remaining are 52 minus 1, that is 51 cards. Therefore, probability of k by k equals 3 by 51. Probability of A by kk is the probability of third drawn card to be an ace with the condition that two kings have already been drawn. Now the remaining cards are 50 cards which have 4 aces. Therefore, probability of A by kk equals 4 by 50. Now by multiplication law of probability, we have probability of kka equals probability of k into probability of k by k into probability of A by kk, which is equal to 2 divided by 5525. Example: two balls are drawn from an urn containing 2 white, 3 red and 4 black balls, one by one without replacement. Then what is the probability that at least one ball is red? Solution: let A denote event of not getting a red ball in first draw and B denote the event of not getting a red ball in second draw. Therefore, required probability equals probability that at least one ball is red. That is equal to probability that none is red, which is equal to 1 minus probability of A intersection B. Now it can be written as 1 minus probability of A into probability of B by A. Now probability of A is the probability of not getting a red ball in the first draw. That is probability of getting another color ball in the first draw. So it is equal to 6 by 9, which is 2 by 3. When another colored ball is drawn in first draw, there are 5 other colors, white or black balls and 3 red balls, out of which one other color ball can be drawn in 5C1 ways. So probability of B by A equals 5 by 8. Now substituting these values in equation 1, we get the required probability as 7 by 12. Example: a bag contains n white and n red balls. Pairs of balls are drawn without replacement until the bag is empty. Show that the probability that each pair consists of one white and one red ball is 2 to the power n divided by twice n Cn. Solution: let Ai be the event of getting one white and one red ball in the ith draw, where I can take the values from 1 to up to n. The required probability is probability of A1 intersection A2 intersection A3 up to An, which can be written as probability of A1 into probability of A2 by A1 into probability of A3 by A1 intersection A2 up to n. Now probability of A1 equals nc1 into nc1 divided by twice n c2, that is equal to n square divided by twice n c2. Probability of A2 by A1 is equal to n minus 1 whole square divided by twice n minus 2 c2. Similarly, probability of A3 by A1 intersection A2 equals n minus 2 whole square divided by twice n minus 4 c2, and so on. Substituting these values in equation 1, we get the required probability as 2 to the power n divided by twice n Cn.